Hello and welcome. In this video, we are going to put in some matrices, do some transformations. We're going to do the classic model view projection stack, which is often used in OpenGL. So just before I get into it, if we pop into the source code here, I've refactored things a little bit. So I mentioned in the last video, we had a bit of technical debt we had to pay off. What I've done is I've got the renderer out to its own class. So in future, we can actually pass in a reference to a scene object and make it more dynamic, make it better engineered. But if we go into the renderer, now we have a bunch of class instances, and hopefully this looks okay. And you can see that I have sort of compartmentalized the different stages arbitrarily, actually. There's no reason to do it one way or the other. But yeah, so first thing we do is set up device, and that handles the adapter, the device, the context, that sort of stuff. Then we create the assets, and that is pretty much loading in the triangle mesh. Then we create the pipeline, which is going through all these steps, just making the pipeline, the bind groups, and all of that. And then we render, which, just set up the rendering encoder. And that seems to work. Okay, so what we need to do is I'm going to change this scene around a little bit. Let's go to the triangle mesh. At the moment, the triangle mesh is just storing X, Y, RGB. I'm going to make this a full 3D implementation. I'm going to set up my triangle so that it is flat along the x-axis, so x equals 0 for all points, and then this, the old x-coordinate, is going to be the new y-coordinate. So the triangle is going to be running across the y-axis and up and down on the z-axis. So just set that up. Okay, we will then need to change the layout. So if we go down, we have now got 6 floating point numbers for each vertex, which would be a stride of 24. This format is 32 by 3 now, X, Y, Z. This is still 32 by 3. The offset has gone to 12 bytes. Okay. Then I'm going to pop over to my shader. And here, vertex position, this is now a 3D vector. And we're not going to put in 0 for the Z. I'm just going to take the vertex position and stick 1 on the end. So this is X, Y, Z, and 1. Otherwise, this should pretty much be fine. But I'm going to just update the shader to include the transform data. So in OpenGL, we would pass this through with a uniform. In Vulkan, we would have a uniform buffer object, and that's where I'm going to do it here. I'm going to make a struct to hold all the matrices, then I'm going to pass that in. Okay, great. So that is our description. We will also need to give this a binding. So we'll go, okay, we'll set this at binding index 0 within binding group 0. So the idea of a binding group is there's only a certain number of things which can be bound on the GPU. Typically, but we can get around that by making binding groups and binding a whole bunch of different resources to that binding group. Okay, so this will be a variable which is a uniform. Its name is going to be transform uniform buffer object, and its type is going to be that transform data structure. Okay, so since we've declared this as a uniform variable, we now have access to it as if it was a global variable. So we can go down here to position, and we can go, okay, get the transform UBO, access its projection. Okay. Hopefully we're familiar with this sort of model view projection transformation series. If you're not, I do have videos on it. But the way this works is matrix multiplication stacks on to the left. So this is, we take the position, we transform it with the model transform that sets it from model coordinates into world coordinates. And then we hit it with the view transform that sets it from world coordinates to view coordinates, which is if I was looking from the camera at a certain position, the world sort of moves around the camera. Then we hit that with the projection transform, and what that does is it pretty much performs perspective division so that things which are closer are bigger, things which are further away are smaller. And that's it. That is our transformation. That's all we need to do there. So the next thing we need to do is we need to pass in matrices. And the question is, well, how do we pass in matrices? Are we going to make a sort of a custom implementation of a matrix? Well, we could. It wouldn't be a lot of fun. What we can do is there's a JavaScript library called GL Matrix, and it's pretty much like GLM in C++ or Pyre in Python. It's a library for creating matrices, vectors, linear algebra stuff. It handles that for us. So we'll go to new terminal and we'll install this. We'll go npm install GL matrix. Okay, that's good. So what we need to do is now let's pop over to it doesn't really matter which order we do this. Let's focus on the transformations first. So we'll go to the renderer and we will import Okay, so we're going to import mat4 four-dimensional matrices, and we'll use them down in this render function. So before we do any command encoding or anything, we're going to create the matrices that we need. Okay, so here's how I'm going to make my matrix, my projection matrix. So it's a bit of a funky thing. I would want to say constant projection equals mat4 perspective and assume that it returns a four-dimensional 4x4 matrix. That's not how GL matrix works. As we can see here, the first argument we put in here is the 4x4 matrix to which the data will be written. So we'll go, okay, write this data to the projection matrix, okay? The field of view, okay, now we know this, we know graphics programming, so we want to be 45 degrees, which it says vertical field of view in radians. So that will be pi on 4 is 45 degrees. Okay. Aspect, that's width over height. Now from memory, I think 800 over 600 is our dimensions. Width 800, height 600. The near distance and the far distance, will go with a near distance of 0.1 and a far distance of 10. We want to keep the near and far distance pretty practically close to each other, because if I make this impractically large, then the depth buffer gets inaccurate as those distances get further. And we could have unexpected results. I've done this. You can set this to like 10,000. It doesn't render things properly. Things which are on top of each other, the order gets reversed. Anyway, I'm rambling. So that is our projection matrix constructed. We'll do the same sort of thing for view. Okay, so we have the look at, And similarly, the first argument is the matrix which you want to store the result. And then we have the I, which is a read-only vec3. So I want to set my camera at a x of -2, so back a little bit from the triangle, a y of 0, so left to right in line with the triangle, and a z of, yeah, let's go with 2, so a little bit above the triangle, okay? And then the center, that is the position that we're looking at, I'm just going to look at the origin. So the camera will be set back a little bit, looking directly at the origin. I'm also going to set an up vector, which I'm going to go just 1 in the z. So typically in graphics programming, if we do nothing else, y will be the up vector, but here I want to set z as the up vector. Okay, so that is created. Then I'm going to make my model transform. And here I'm going to rotate. So this is a little bit funky because now we have 2 matrix falls that we're putting in. The first one is the matrix which will receive the rotation, which I'll say is my model matrix. The other one is, so if we were doing a series of transformations, we would apply a transformation to a matrix and then put the result out into a matrix. In this case, they're both going to be the same. I know, that's a little weird. That's a little weird. The next argument is the rotation. I'm just going to go with 0 for now. We'll come back to that. And then the axis. So I'm going to make this rotate around the z-axis. Okay, now as for the rotation amount, I'm going to fudge this a little bit for now. So I'm going to go back up and I'm just going to go t, which is a number. I'm going to encode a little bit of state into the renderer at the moment. It's a little bit dodgy. We'll fix this up later, but this is just for the example. Okay, so we'll go 0.0. Okay, and we'll go. The radians that we're rotating are this t. What? Why are you complaining? Argument of type number is, oh yeah, okay. Class number versus primitive number. Okay, well, we just want to go back up and make this a primitive number type. That's fine. And there we have it. Okay, so we've made these 3 matrices, but then the question is, how do we sort of put that into the shader? Now we know that we have, where are we? Let me go back to the shader. We know that we have this transform data, which is a uniform. It's binding 0 within group 0. So I guess first of all, we need to sort of allocate space to hold that. So we'll go back up and here we have bind groups. Okay, let's make a uniform buffer. Okay, so we've got a uniform buffer there. I'm going to allocate the buffer when I go to make the pipeline. So I'll go down to the make pipeline. And I'll say, okay, because I'm gonna read the uniform buffer and set it up in the bind group down below. Okay, so uniform buffer, I go create buffer, and I'll set that descriptor, the size of the buffer. We have a 4x4 matrix. 4 times 4 is 64. Sorry, no, 4 times 4 is 16, but each of those numbers within the matrix is a 32-bit floating point number. So that's 4 bytes per number, 16 numbers. Okay, so every matrix, every 4x4 matrix has 64 bytes. And I've got 3 of those model view projections. So the size will be 64 times 3. I also want to set the usage. Yeah, because I'm going to use it in the uniform buffer, as a uniform in the shader, and I also want to be able to write data to it. Okay, that is looking good. So then I go to the bind group layout, and now I've actually got stuff. So I'm just going to describe the layout is where I describe the basic things which will be there. I don't actually bind them. So I go, okay, let's go binding 0. And then I have visibility. I'm going to use this in the vertex shader. So GPU shader stage vertex. And I'm going to specify that I'm binding a buffer. So I'll say buffer is nothing, but this is just specifying that it's a buffer resource which is being used here. Okay, then I go to the bind group, and this bind group is where I actually declare which things are going in there. So in the entries, I say, okay, this is going to go to binding 0. And the resource is a buffer, which is this uniform buffer. Okay, just checking through that, and the rest of this is okay. That's all fine. So just get that out of the way. There we have it. So again, we create the uniform buffer. Then we declare that we're going to use a uniform buffer in the bind group layout, and then we declare which uniform buffer we're using. Okay. Then we can go down and actually write these matrices onto that uniform buffer. The uniform buffer exists all the time. The shader will always be reading from it. So all we need to do is write that data in, and it will be read. So we get the queue on the device, and we call the write buffer function. The first argument is, what are we writing to? We are writing to our uniform buffer. Next argument is the offset. Well, you see, when we write the model, because we go model view projection, when we write the model, we're starting at the first matrix, which is an offset of 0 bytes. Then let's go. Let's cast this to an array buffer. Send that in. And then we'll write the view. And the view will be the next matrix along, so 64 bytes after the model. And then we'll write the projection. And that will be another 64 bytes into the structure. So there we have it. Let's sort of run that. Okay, just a standard warning. That's fine. Okay, then we'll just open this up. Alrighty, let's check the errors. Unknown identifier. So it looks like I've really messed it up. Okay, let's see what's going on. What a mistake to make. It's not a transform, but rather a transform. Jeez, okay. Sometimes I really wonder. Okay, so now we've got our triangle, check the console, no errors. It doesn't look very transformed though, does it? It sort of looks pretty similar to before. So in order to better see this transform, let's set this up so that it's actually sort of repeatedly rendering. We'll go to our render function, and again, this is sort of dodgy, but we'll just go with this for now. Yeah, we'll go with that, 0. Yeah. Okay, cool. So we're updating our t variable. And we're just checking if it overflows beyond 2 pi, because it's a circular motion, so it shouldn't make a difference. All right, so we can go and build that again. And check that. And it's done something, but as you can see, it's not updating. So what we need to do is we need to set up, I mean, obviously, right? This function is only being called once. So we need to set this up in an animation loop. And one way to do this is with a function called request animation frame. So we go request animation frame, and then we put in here the callback function. That'll be this render. And we can try this again. Nothing's happening. Check the console. Uh-oh. Uncaught type error. Cannot read properties of undefined. Reading T. Well, we should know what T is, right? So it turns out we need to do one more thing, and that is we need to take this function and declare it, sort of like pre-bake it like a lambda, if you know what I mean. So we'll say take this and save it as an object, and this sort of pre-bakes the reference to this, if you know what I mean. The problem is it won't be able to, the way we were doing it before, it just wouldn't be able to see any of the class variables because of reasons. No, because it sort of says, it passes this back to the animation handler and it doesn't really know. It's a little bit weird. It's a little bit funky. But anyway, let's go back here. Retry that, and now it's spinning. And it is spinning just a little too fast. So I'm just going to, I think in my notes I had 0.01. There we go. Okay, so that's working, and then we go back, and no errors. That's looking good. So yeah, there we have it. So yeah, in this video we had a look at uniform buffer objects, how to make uniform buffers, how to pass data into the shader, and how to set up a sort of render loop. Anyway, hope you enjoyed, and I'll see you again soon. Bye.